Hi everybody. Today I would like to tell you about a new feature in our software. And this feature is very important for people who make a fire testing. And I know that in some countries, our customers who work in fire departments must do the tests with exposure of the material under fire conditions. And in this case, I will not speak about some special instrument, but I will speak about predictions for special fire conditions, fire temperatures. If we here will be 4 points. First is predictive possibility, general predictive possibility in Kinetics Neo, then the different types of the fire and predictions in Kinetics Neo for different types of the fire, then measurements for fire predictions and one application example. Generally, in Kinetics Neo, if you would like to know what happens with materials at high temperature, then we put this material into oven, into furnace, and make some heating of this. And it doesn't matter what we measure. We can measure mass, we can measure DMA, we can measure evolved gases, for example, in gas analyzer, like it was right now. So we measure some property of material. And in this case, now the easiest way to measure is thermogrammetry, but again, it could be another type of instrument. If we see the mass loss with temperature, then probably it's some kind of decomposition or combustion. In any case, something happens with material. If you make a same with different heating rates, slow heating, fast heating, then we will be able to create one kinetic model for this data with different heating rates. How it works? Firstly, we make measurements under controlled temperature, for example, constant temperature, then import data in Kinetics Neo, create kinetic model, and if one kinetic model can describe data at different temperature conditions, then we can make a simulation. Isothermal, dynamic, or arbitrary, or for special conditions, for example, for different types of the fire. Now in kinetics we have a different predictive possibility. The first one, very simple, isothermal for different constant temperature. Another is dynamic for different constant heating rates, slow heating, fast heating. Here is multi-step with several segments, isothermal or constant heating or cooling rate. Step ISO, like stair with heating isotherm. Modulated, oscillation around constant heating or isothermal. Adiabatic, just to see how temperature increase because of exothermy. But all the things are really artificial. And in reality happens totally different, and temperature profile is not so easy like a constant heating and constant temperature or isotherm. In reality, we have, for example, for climatic conditions, some very complex temperature profile with changing of temperature depending on season, day and night. And the customer must just select if he would like to make predictions for Boston, Munich, Shanghai or Sydney. If you have industrial big machines, again, the temperature profile is not so easy like constant temperature. It's something very complex inside. And for big machine, we must usually record this temperature profile during the production process. Now we are able to put it into the software and make predictions according to external temperature profile. And now the topic of our presentation today is the fire. The temperature of fire is really very complex, and it depends on the type of fire. If you have a fire of house, just normal house, it's not really the same as the fire for petrol station, you see, because we have different materials for burning. And in this case, in the software, we have predictions according to different temperature profiles, according to different fire presets. And now about types of fire. There are international standards, and our customers work according to this standard with fire resistance tests, and they must expose material according to the standard time temperature curve, and then see what happens with material. If you go to European standards, then there is not only one temperature profile, but several temperature profiles. For example, heating curve, hydrocarbon curve, external fire curve, slow heating curve. Here is the fire resistance test. Another is again European standard 1991. Here we see again different fire curves: standard curve, external fire, hydrocarbon curve. And you see that it's Europe standard, but I know some non-European countries who just translate this European standard to their own language and use as a national standard in the fire testing for inside own country. So I mean that everything what is here works not only for Europe, but for some countries outside of Europe. And now about different types of the fire. The first is very common, which is in ISO standard, this so-called standard temperature fire curve. Another name is the heating fire curve or cellulose curve. This curve shows the temperature increase if you have a fire of a normal house or normal office, normal furniture, as standard building materials. Here, the increasing of a temperature goes fast during the first 5 minutes, and then increasing of the temperature is logarithmic. After 30 minutes, it's about 800 degrees C. If you would like to know what happens with materials or just make predictions in the software according to this temperature profile, then we should select in the software preset which called standard cellulose curve. Another type of fire is so-called hydrocarbon fire. It has a name hydrocarbon curve or oil curve in different standards. This fire shows how the temperature increase somewhere on the petrol station, on chemical factory, in fuel tanks, or maybe oil tankers. And in this case, you see that the temperature profile is totally different. Here, increasing happens very, very fast. In the increasing of a temperature happens very, very fast, maybe about first 2 minutes up to 800 degrees C. And after that, there is some kind of saturation of the temperature for the final temperature above 1000 degrees C. It's really high temperature. This is a second type of fire. A third type of fire is so-called external fire. This external fire shows what is the increase of the temperature inside the closed room if the fire is outside of this room. You see that here the final temperature is just a little bit about 600 degrees C. It's relatively low. This external fire is usually used in order to predict what happens with the fire if we have a house with several floors or several rooms. So how the fire goes from one room to another room, how the fire goes from one floor to another floor. In this case, our customers and we also use this external fire curve. And if you would like to use it in kinetics, then we should select preset which called fire external. And next one, the last one type of fire which is inside of our software, it is so-called slow heating curve. It's called smolder. In this case, the temperature increase has two parts. a first one is slow temperature, about 300 degrees C during the first 20 minutes. Here we have a burning of maybe paper or clothes, and the temperature is really not very high. And after 20 minutes, we have a really very strong temperature increase, and a second part of the curve is the real cellulose fire, where we have a burning of the wood and all other things. So for this case, we have two parts, but they are in one profile, and if you would like to make predictions in the software according to the slow heating, then we should select preset fire for slow heating according to standard EN 1363. These four fire curves right now in Kinetics Neo, and you can just use your kinetic model and make predictions according to these different types of fire. And now about measurements. Here you know that in our laboratory we can, for example, with the standard measurements, we can perform the measurements either without any oxygen in inert atmosphere or with oxygen, if we have enough oxygen, for example, in synthetic air. But you know, in reality, it happens not the first case, not the second case, but something between. During the real fire, we have some amount of oxygen between no any and between enough. In this case, we can refer to the standard EN 1363, and it is recommended to make the measurement in laboratory with the oxygen content about 4% for testing of specimens with no combustible content. In this case, we will recommend to our customer to perform the measurement with the 4% of oxygen and then make kinetic model according to this data and make the predictions according to different fire curves for this data. And some application example I just made very, very easy based on TG. But in this case, it could be another type of instrument and another property of material which could be predicted. Here we have TG, decomposition of polymer in inert atmosphere. We have two-step kinetic model. And then we can use this kinetic model to see what happens with this polymer under fire temperature curve. We open our software, select external temperature profile, here somewhere, then select for this profile one of 4 existing presets. In this case, it's according to the slow heating with 2 parts, and then press calculate. We see 2 curves. One curve is dashed curve. It's a temperature increase. For this profile, it has 2 parts, a slow heating for first 20 minutes, and then the cellulose curve after 20 minutes, high increasing of the temperature. And for this temperature profile, we are able to make predictions of decomposition for this polymer. We see that the first 20 minutes decomposition goes slow, and then during the second part of our curve, burning curve, we have very, very fast decomposition of this polymer. Another example is done not in inert atmosphere, but in synthetic air. Here is decomposition of polypropylene. We have 4-step kinetic model, and again, predictions according to slow heating. We see that, again, dashed curve is our temperature, green curve is our behavior of our material, mass loss. First 10 minutes during the fire happens nothing. Then next 10 minutes we have mass loss as about 70%, and then next 2 minutes the decomposition is complete. We have all actual information on our Kinetics Neo website, kineticsnitch.com, and here you can get user guide, training examples. You can get a trial version for 30 days and see our webinar from this site with some unique features in Netsch Kinetics Neo software. Thank you.